It's done, we have their opinion, which is their opinion. Is basically they're stating that we're patentable, and so there's no prior art that suggests it. Now we're talking about a groundbreaking technology, and I want to show you here. What we're going to do is a simple demonstration here. I want to show first, for the engineer type fellas out there, this is going to be the technology that we're going to be using this evening. And if you take this off, you'll see this is the actual technology we'll be using. The little piece right there is the actual technology. It's just a bundle of wires. And for the engineers out there, if you did this and you had a power source in here, it would be pretty bad experience for you. If you had one that was going to produce what we're going to be producing here. And get that on there. Okay, let's just hook it up like this and touch these together. As you can see, they're held together quite nicely, and I'll hold them together even nicer than that. So there's no power source there whatsoever. The next thing I'd like to do is this meter here is the one we're using right here. It is set on bolts right here, and we're going to take and we're going to hook this one to the black and this one to the red. And it's still zeroed out. Okay, and now to even take it to the next step, we're going to hook this into here and this into here, and as you see, once again, there's nothing. And we're set on 20 volts 20 volts DC, so it would pick it up anything. We flip it over, we do the same thing here. Once again, no power outputs. And then our final thing we're going to be doing is we're going to be hooking this to this and all of our positives together as well. Wonderful. Oh, it's going to fight it with us a little bit. Okay, let's do the hard way. Okay, and once again, there's no power there. And of course, we'll touch them together. We zero them out. Okay, so if you're not satisfied with that, we'll be glad to show you in person. And this is to be the technology we'll use, and we're going to characterize the solar cell here. I'm going to put this back in here. This is just a box. And we're going to set this back in here. And we'll move this. This usually sets like this. We just keep it hid. We're going to characterize the cell, our solar simulator. It's been raining and snowing a couple days. And our solar simulator here. This is a solar cell here. We have a 200-watt light bulb. And we have it pinned right here, and we also have the solar cell pinned right here, so we won't be moving that. And if you'll follow these leads over here, you'll see we're at 1.76 volts. 1.76 volts. We put this around the 10 amps. We move this to the amp position, and we're at 18 amps. Well, it's kind of trying to titrate up. So, getting a little degradation, 1.71 at 0.18. So without the technology, our volts is 1.71 and our amps are at 0.18. So we multiply that 1.71 times 0.18 equals 0.20178. 0.20178. Okay, so now we're going to intersect the technology. We're going to be using the same meter and the same solar cell. We got the capabilities of the solar cell. And we're just simply going to hook the input to the technology here with the same solar cell. And we're going to be hooking it to the same meter. And we're still on 20 volts. We're going to turn the light on. And this is with the technology. It's 5.63. 5.63. So our volts are 5.63. 0.63. So you can see that we have a relative increase in voltage here. One of the amazing things about the push of inductive current amplification and harvesting is that we're able to maintain a relative current stability while increasing voltage, and everybody knows in Ohm's law, you bring up voltage, it's going to be proportional to down with amperage, you bring up amperage, and we're still going to be able to do that because it's known that inductive current itself and across an inductor it stores. So our technology has found a way to maintain that while getting an increase of voltage. So now we're going to switch this back over to 10 amps just like we did before. We're going to move this to the amp position, and we're going to turn it back on, and we're at 0.18. 0.18. So you'll see the stabilization there. That's one of the most incredible things that we do. So it's 0.18. So we're going to multiply that. We're going to say 5.63 times 0.18 equals, I'm going to write that in two places. I'm going to write it here underneath this one, which is 1.0134. 1.0134. Now, once again for the engineers, I'm going to clear this. I'm going to put the bigger number, which is our number, of course. I'm going to put that over here, which is 1.0134, and I'm going to subtract this number, which was the number of what the solar cell was capable of by itself, which is 0.20178 equals. So as you can see by those numbers, we are getting a heck of an increase. So anyway, if you take the technology and let's just say you had 1 volt and 1 amp, and you times 1, you're going to get 1 watt. So if I increase the amps, it's going to increase the wattage because it's going to be times the volts. What we did was we increased the volts, and so it's going to still give me that much more wattage. It's important to understand about the technology. It's one of the greatest things that we do. So our solar demonstration, I'm going to run through it on a dry run for people. We're using this meter. We're coming from this meter right here. Of course, there's nothing underneath here. Don't look, just in case. And we're running these wires right here. And we're just going to do it in reverse just to show you the numbers again. This is with the technology. It's already in on the amps. So we're at 0.18 with the technology. And the voltage is 5.63 right here. So it's 5.63 at 18. That one checks out. Now we're going to go over here to without the technology. We're simply going to disconnect the technology here and disconnect it here. And we're going to, once again for the engineer guys out there, we're going to just hook all these up together. If there's a short, there's a short. But there's not any. Once again, that's all there is. Okay, so now we're just going to characterize the cell by itself. There'll be a little heat degradation. That's standard in solar. Okay, and we're at 1.68 volts. 1.68. We were at 1.71. I know there'd be some heat degradation. And on amps, we're probably going to go up a little bit. Yeah, 0.19. There we go. Okay. And that ends the solar demonstration. And like I said, you know what this would do for solar. If you had a solar field, and it's $1 million solar field, you got at least a $2 million solar field now. But for homeowners and everybody, you can see the benefit of this. So that concludes the solar portion of the demonstration. And next we'll show you what this same technology will do with the. Oh, I got one more thing to show you. I'll show them on solar, babe. Right here. If I take this, we're totally disconnecting the meters now. This is just a little 12 volt motor, and I'm just gonna hook it up here. Okay, and I hook that up and I can push this all the way, literally. I mean, I literally can get it all the way down. I never had to rack and get it down closer. You can see how close I've got it. I think I'm just about touching it. And take a look there, and that motor ain't budging, and you see I'm well connected here. See there? Okay, I just want you to see that we have a real energy increase. So once again, we're going to take this, we're still going to slide the technology in there. Everybody see that we had that baby all hooked up to where you can tell if there was any shorts in there. And we're just going to hook this to the solar cell to show you our increase is real. Once again, it's a 12-volt motor, that little fan motor, and oh, well, thank you for that. I don't know if it's polarity sensitive or not, but thank you for that anyway. Okay. Okay, let's see if we can get that baby going. I don't know if they can see the motor running or not. Well, they can hear it. It is turning. Keep the shot on the motor and disconnect it. Reconnect it. I can't believe I have to start that thing by hand. Probably wouldn't have to if I pushed it down like that, would I? Oh no, it's doing it now. And so that shows the increase, and once again I'll show you without the technology. They only get 78% of solar out to use, the solar energy that they're getting, and so 78% of what's coming from the cell is kind of the industry standard as to how much of it gets out to good use. So 100% of this cell won't run this motor, so we must be getting more than the 100% the cell's capabilities of. Oh, it's already on. I'm actually touching the cell with it. I want to shorten it. Roll it with your finger, try to get it going, do anything you want to, you ain't getting it going. I could burn the cells up, it ain't going to go. Okay, that does conclude the solar, and I thank you for your time.